Hello, this is Chapter 7, Section 4, Arclength and Polar Curves. So we know from pre-calculus that a polar curve is always represented by the equation r equals f of theta, where theta is the angle between bounded by alpha and beta. So a polar equation is always written as r equals f of theta. Now, here the assumption is when we say the theta is between alpha and beta, we are assuming that the curve, the polar curve, is not winding like this. Okay. So it may look like this, not like this, where it's winding around some given point. So in that case, to find the arc length, how long is that curve that is given as a function of theta, which is the in polar coordinates. In polar curve, we use this formula: L equals the integral from alpha to beta of the square root of r squared plus dr d theta squared, and d theta. So we integrate in respect to theta, and theta is between alpha and beta. So it integrated from alpha to beta. R that is square here is from this equation r equals f of theta. Dr d theta is you take the derivative of r and then you square it. So let's take an example. It says find the length of the cardioid r equals 1 minus cosine theta on the interval 0 to 2 pi. So theta is between 0 and 2 pi. So if you graph it, the curve looks like this. This is how the cardioid look like. When you graph r equals 1 minus cosine theta, theta is between 0 and 2 pi. So it looks like this. So the question here how long is this arc length? How long is this arc? And this arc is given as in polar coordinates. The polar coordinates are r comma theta. So when you look at the formula says to take r, that is 1 minus cosine theta, we want to square it. Okay. So if r, we square r, it means we square the right side also, which means we're going to FOIL it. You get 1 minus 2 cosine theta plus cosine square theta. And then the second part says to first take the derivative of r. So we're taking the derivative of r with respect to theta. So r prime is a dr d theta. So when you take the derivative of 1, you get 0. Derivative of cosine theta is negative sine theta. So negative and minus makes it positive sine theta. And then you square it, you get sine squared theta. Then under the square root, we have to add r squared with r prime squared. So r squared is 1 minus 2 cosine theta plus cosine squared theta. R prime squared is sine squared theta. So when you add the two, you're basically going to add 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta. So we end up with cosine squared theta plus sine squared theta. We know by definition of trigonometry, this is 1. So you have 1 plus 1, which means 2. So you end up with 2 minus 2 cosine theta as r squared minus r prime squared. So that will go under the squared sign. So the square, we take the square root of both sides of this equation, and we end up with, and then we integrate from 0 to 2 pi. We're going to integrate the square root of 2 minus 2 cosine theta. Here we can factor out 2, under the square root. So we need this. How do you integrate this? To integrate this, we need some kind of trigonometric formula or identity. So we go back to the general trigonometric identity. We call this the double angle formula. which is says 1 minus cosine 3 theta all divided by 2 equals sine squared theta. But here we don't have, here we have 2 cosine theta, 2 theta. Over here we have theta, so it's not the same. So how do we make this 2 theta to become theta? So then this comes, if you divide 2 theta by 2, you're going to get theta. So if you do this angle, whatever you do with this angle, you should also do it with that angle there. So when I divide 2 theta by 2, then I should also divide theta by 2. So when you divide, so you simplify it, you get cosine theta. So 1 minus cosine theta all divided by 2 equals sine squared theta over 2. Now we can see we have 1 minus cosine theta, and then we have 1 minus cosine theta as a numerator. So to get 1 minus cosine theta alone here, I should multiply both sides of this equation by 2. So when I do this, I get 1 minus cosine theta equals 2 times sine squared theta over 2. But we also have a 2 here, so for me to get a 2 times quantity 1 minus cosine theta from here, I should multiply again both sides of this equation by 2. So when I multiply by 2, I get 2 times quantity 1 minus cosine theta equals 4 times sine squared theta. So this is going to go under the square root sign. So when I replace 2 times quantity 1 minus cosine theta by 4 times sine squared theta divided by 2, I will then take the square root of 4, give me 2, and then the square root of sine squared give me sine. So I end up with this. And then I can just integrate. So we know the antiderivative of sine is negative cosine. But then it's going to be negative cosine of theta over 2 divided by half. That half is coming from theta over 2. So we kind of use the substitution rule. So when you divide something by a fraction, you can flip or multiply. So you get 2 times 2, which is 4. And then from here, I have a negative cosine theta over 2. I can plug in 2 and 2 pi and 0. So 2 pi first. Get 2 pi over 2, which is just pi, cosine of pi. And then a 0 for theta gives you cosine of 0. Cosine of 0 is 1. Cosine of pi is negative 1. So you give negative 1 minus 1, you use negative 2. Negative 2 times negative 4. So negative here is this negative that we took it from here. So negative 4 times negative 2 is negative 8. That's the arc length for that particular polar curve. We go back to the next example. Again, find the arc length of the polar curve given by r equals theta squared, and theta is between 0 and 2 pi. So again, we take r, we square it, we get r squared equals theta to the 4th. We take the derivative of r, we get 2 theta, we square that. We square the derivative, we get 2 theta squared, which is 4 theta squared. We add r squared with r prime squared, which means theta squared plus 4 theta to the 4th plus 4 theta squared. You can see here we have a theta squared as a common factor. We can factor out theta squared and then take the square root of the product. We do the distribution of the square root. The square root of theta squared is theta, and then times the square root of theta squared plus 4. So that's what you're going to integrate. But then when you can see this, it's basically the u substitution. If you let u be theta squared plus 4, what's under the square root sign, then du is going to be 2 theta d theta. But we have a theta d theta already, so all you need to do is just divide this by 2 to get theta d theta, which is du over 2. So here I decide not to change the limits of integration. So I keep copying theta equals 2 pi and then theta equals 0, because that's what it is here. The square root of u, and then we know theta d theta is a d over 2. So I can bring a half outside, change the square root to 1/2, fraction exponent, and then integrate using the power rule of integration. So you add 1 to the exponent, divide by a half plus 1. Dividing by 3/2, you can flip, since it's a fraction, you can flip or multiply, get 2/3 times a half. You can simplify half, 2 by 2, you get 1/3. And then here you can then, you don't plug in theta. These are theta. It's not u. So you keep writing theta equals 2 pi and then theta equals 0. So then you can go back and replace u by theta squared plus 4, because remember, we let u equals theta squared plus 4. So we bring theta back with that substitution. So theta squared plus 4 is u. So it's going to be quantity theta squared plus 4 all raised to 3 halves. Now we can evaluate at theta equals 2 pi and then theta equals 0 because we got theta back. So you plug in 2 pi for theta here first, and then a 0 for theta again in the same expression, and then you take the difference. So 2 pi squared is 4 pi squared plus 4 raised to all raised to 3 over 2 minus 0 plus 4 is a 4 raised to 3 half. 4 raised to 3 half is 8. So you get the arc length is 1/3 times quantity 4 pi squared plus 4 all raised to 3 half minus 4. So that's the arc length.